Imagine stepping out of your apartment, tapping an app, and a sleek electric vehicle glides silently to the curb. The door opens automatically. You step inside, and notice there's no steering wheel, no pedals. The front seats face the back, creating a cozy lounge. You settle in, the door closes, and the car just goes smoothly, confidently, navigating city streets with calm precision. It yields for pedestrians, merges into traffic, and keeps a perfect distance from other cars. All without your input. You're not watching the road, you're catching up on emails, sipping coffee, watching the news. This isn't science fiction. In select cities, it's already real. At first it feels strange. Your brain keeps searching for a driver, but soon, trust takes over. The car sees things you don't, anticipates actions, and processes the world in real time. This isn't just cruise control, it's a redefinition of personal mobility. The leap is massive: robotics, machine learning, and engineering working together to handle thousands of micro-decisions every minute. Handing over that responsibility to a machine is a huge step, and it's happening now. The driverless car is no longer a concept, it's a service. It's changing how we think about travel. The future of transportation is arriving, one quiet, driverless ride at a time. The question isn't if you'll ride in one, but when. Welcome to the era of cars with no drivers. The secret? AI. Self-driving cars rely on artificial intelligence, specifically machine learning. This isn't movie-style AI plotting world domination, it's practical, focused, and trained for one job: navigating real-world chaos. The AI is a prediction engine, constantly asking, what's next? It predicts a cyclist's path, anticipates a child chasing a ball, and plans accordingly. It's not just reacting, it's thinking ahead. The AI is fed non-stop data from advanced sensors, giving it a 360-degree multi-layered view of the world. It never gets tired or distracted. Its only job: make the safest, smartest decision millions of times per second. Training this AI isn't about coding every scenario. Instead, it learns from millions of miles of real and simulated driving. It recognizes stop signs in rain, snow, or when obscured. It learns the difference between a delivery truck and a sports car. With every mile, it gets smarter. The result? An AI that can handle the unpredictable just like a human, only faster and more reliably. This is the brain behind the wheel. It's not magic, it's relentless learning and adaptation. That's how the car drives itself. Cameras are the car's eyes. Dozens of them, all around the vehicle, capturing a high-res, 360-degree view. They read street signs, traffic lights, lane markings, and brake lights, providing rich context and detail. Cameras help the AI classify objects: pedestrian, cyclist, or traffic cone, police car, or just a blue decal. But cameras have limits. Glare, darkness, rain, or a dirty lens can blind them. That's why they're just one part of the puzzle. Advanced image processing helps, but cameras alone aren't enough. Some companies like Tesla bet big on vision-only systems, pushing computer vision to its limits. But for most, cameras are just one essential sense among many. LiDAR is the car's superpower for precise measurement. It fires millions of laser beams per second, mapping the world in 3D with millimeter accuracy. Day or night, LiDAR builds a detailed point cloud of everything around the car. Lanes, curbs, cyclists, pedestrians. It's objective, unaffected by lighting, and crucial for tasks like parking or navigating tight spaces. LiDAR's precision gives the AI confidence and a huge safety margin, but it's not perfect. Heavy rain or snow can interfere, and the tech is still expensive. Smaller, cheaper LiDAR units are coming, but it's not a silver bullet. LiDAR is a powerful tool, working alongside cameras and radar. Together they create a complete picture. Radar is the all-weather workhorse. It sends out radio waves that bounce off objects, seeing through rain, fog, and dust. Radar excels at detecting large metallic objects, like cars, and measures their speed instantly. It's vital for highway driving and adaptive cruise control, but radar's view is fuzzy. It can't always tell a plastic bag from a small animal. That's why it works best as part of a team. Radar provides robust velocity data, while cameras and LiDAR deliver detail. Together, they cover each other's blind spots. The real magic is sensor fusion, combining cameras, LiDAR, and radar into one unified model of the world. Each sensor has strengths and weaknesses, but together, they create a detailed, reliable picture. In fog, radar sees what cameras and LiDAR can't. The AI cross-checks all data, filling gaps and confirming threats. This redundancy is key to safety. The AI predicts what every object might do next. Will that cyclist swerve? Will that car change lanes? Then it plans the car's path, updating constantly as new data comes in. Millions of calculations per second keep the ride smooth and safe. It's like having three superheroes comparing notes, always ready for the unexpected. This is how self-driving cars handle the chaos of real roads. It's not just smart, it's resilient. This tech isn't just in labs, it's on real roads. Waymo and Cruise run driverless ride-hailing in cities like Phoenix and San Francisco, using full sensor suites and high-def maps. Their approach, redundancy and safety, with vehicles designed for autonomy from the ground up. Tesla takes a different path, vision only, using cameras and neural networks, learning from a massive fleet of consumer cars. In China, Baidu and AutoX are racing ahead with robotaxis in major cities, backed by huge data and government support. Each company's strategy is different, but all are pushing the boundaries. Their competition accelerates progress for everyone. The future is a global race, and it's speeding up. Why all this effort? The biggest reason is safety. Human error causes most crashes. Autonomous cars don't get tired, distracted, or drunk. The potential to save millions of lives is enormous. Efficiency is next. Cars communicating, flowing through intersections, reducing traffic and energy use. Self-driving cars could transform accessibility, giving independence to millions who can't drive. They'll turn commutes into productive or relaxing time, and let cities reclaim space from parking lots. The car becomes more than transport. It's a mobile office, a lounge, a new kind of freedom. This isn't just convenience, it's a chance to reshape society. The benefits are profound, touching safety, time, and quality of life. That's why the world is racing to make it real. The promise is huge, but challenges remain. Edge cases, rare, unpredictable scenarios, still trip up AI. Bad weather can blind sensors, and no system is perfect in all conditions. Legal and regulatory questions, who's responsible in a crash, are still unresolved. Public trust is fragile. Every incident is scrutinized. Building confidence takes time, transparency, and real-world proof. The road to full autonomy is long, but progress is steady. Despite obstacles, progress is accelerating. Fleets drive non-stop, gathering data, retraining AI, and improving with every mile. Real-world and simulated miles create a feedback loop. Smarter cars, faster learning. Investment is massive. This is the future of transportation. We'll see more driverless ride-hailing, then autonomous trucks, and eventually personal cars with true autonomy. The timeline is shrinking every year. It's not if, but when. The driverless revolution is well underway. We've explored the tech, the companies, the benefits, and the challenges. This is one of the most disruptive changes of our time, and it's happening now. The shift will be gradual, but it will reshape cities, economies, and daily life. The conversation matters. How we guide this technology will shape its impact. So, what do you think? Does a driverless car excite or worry you? What's your biggest hope or concern? Share your thoughts below. Let's talk about the future we're building together.